Okay, this is the Math 1113 Zoom meeting for November 10th and the week of 11/9 to 11/13, and we're doing section 7.3 this week. Practice problems on page 597, 3 to 81 odd. We'll have quiz 10 on Friday, due Sunday. We'll be over these problems. Web assigned problems, section 7.3, problems 1, 3, 4, 5, 6, 7, and 8 only. Email me the percent of these 7 problems you get correct. There are 7 there, yes, that you get correct. So let's show you what's going on in 7.3. It's going to be more formulas. Chapter 7 buries you in formulas. So 7.3, show you the groups. They kind of group them out: double angle, half angle, product, sum formulas. So what happens is, I'll show you this. We'll maybe show you a couple just to convince you, and then we'll just use the others. Where this one is used a lot. Sine of 2x is used a lot. Cosine of 2x has got 3 different versions, and a tangent 2x never hardly ever see used. Let me show you where they come from, and then we might believe some of the others. All right, double angle formulas. Start with a sine. They're going to use the plus version of, I'll use an x and a y, or you could use an s and a t. If you remember, it went sine first, cosine second, plus cosine first, sine second. All right. And then set x equal y, and we'll use x. So that's a sine of x plus x. We're going to put in a x wherever there's a y. So we'd have sine x cosine x sine x. Well, x plus x, there is 2x, and that is where you get your double angle. Well, if you notice, these are like terms. They're absolutely identical. This one switched from this one, but that shouldn't bother you. One of them plus one of them is 2, and they always, for some reason, write the sine first. 2 sine x cosine x. So in effect, it's almost like the 2 pops out, but you do get a product of sine x and cosine x, and it's used to reduce an angle. All right. Notice you don't use x minus x. Remember, that would have been a, well, that'd be sine of 0, which is 0, and you get nothing. So we're only using the plus version. Plus version. All right. So this is very important. It's used a lot. All right, try the same game. Cosine of x plus y. Remember, that one: cosine x, cosine y, opposite sign, sine x, sine y. Same game, set x equal y. Cosine then of x plus x, or y equals x. Cosine x minus sine x. There's your cosine. This is version 1. 2x cosine squared x minus sine squared x. Okay, so that's one version of it. I'm going to start with that. That's the version right here, cosine squared minus sine. That's the first version I think of when I think of a cosine of a double angle. It's a cosine squared minus a sine squared. All right, start with cosine of 2x is cosine of squared of x minus sine of x. Remember, a sine squared plus a cosine squared equals 1. So you can sub in either one. Let's sub in cosine squared 1 minus sine squared. Sub in. Well, you'd get a cosine of 2x is 1 minus sine squared. That's for this minus sine squared. Well, one of them minus one of them, that'd be a negative 2 of them. 2x equals 1 minus 2 sine squared x, and that is where they get this version. All right, that's version 2. All right, for version 3, sub in sine squared 1 minus cosine squared. So you get cosine of 2x equals cosine squared of x minus, and then 1 minus cosine of x. So this is cosine squared minus sine squared. Sine distributes. The minus sign distributes. So you get cosine squared of x minus 1, add x. And finally, version 3. Cosine of 2x is then twice cosine squared of x, subtract 1. One of these plus one of these is 2 of them. So there's 3, that's a little more kind of 3 versions of that can be used. And just for completeness, I'll show you the tangent. Tangent, double angle. Angle for tangent. Tangent of x plus y. Remember, that was almost like it distributes on top. Tangent x plus tangent y. But bottom is 1 minus the product. Same game. X equal y. X plus x. Tan x plus tan x over 1 minus tan x tan x. You see the 2 different things you can do with these. One of them plus one of them, there's 2 tan x. When they multiply, they're identical, so that's 1 minus tan squared x. And I froze. That's a shame. It's working really good. Okay, here we are, if it'll keep going. Okay. And that is version 3. All right, let's try some, before we show you and just really blow your mind, see, we've got half angle formulas. Before we blow your mind with anything like that, let's just go ahead and show you what they want you to do with those. This is long enough, it'll fill up the material for a whole week. And we'll have to do 2 sections to finish up next week, 7-4 and 7-5, and we'll be done. All right, just to show you what the kind of homework they're going to want you to do, page 597 off the homework. Guess we'll start with the first one, number 3. It's more of a project because you look, they're given sine of x is 5/13, x in quadrant 1. They want you to find, they didn't number them, I will, sine of 2x, cosine of 2x, tangent of 2x. There you are. Quadrant 1, find these 3 things. Okay. Draw a triangle. Quadrant 1, see when the different quadrants can give you different signs. All right, sine is opposite over hypotenuse. Are you good enough to figure out that this is 12? X squared plus 5 squared, if you want to see it, 13 squared. X squared plus 25 equals 169. X squared would equal 144. So x is 12. Now, if it was, say, quadrant 2 or 3, it'd be a negative 12. The triangle would be over here or here. But if it's quadrant 1 or 4, that x side's positive. Okay, it's just plug and chug. Piece 1, a sine of 2x. That was twice a sine x, cosine x. Well, you're already given sine x twice, 5/13. Cosine x then is adjacent over hypotenuse. That's 12/13. If you want to multiply these out, leave it in fraction form. 5 times 2 is 10. 12 would be 120. 13 times 13 is 169. Notice less than 1. All double angle means is that you're going around the circle more. Your angle is bigger, so you're going around. If this is x, then say over here 2x, or if x is small enough, it's still in first quadrant. It just means you're going around the circle more. You're doubling your angle, which means you're traveling around the circle. Traveling further around the circle. But the same rules about sine and cosine being less than 1. Actually, if you want to be really anal about it, it's technically less. Sine could be 1. Technically, less than or equal to 1. All right, I'm going to, number 2, a cosine of 2x. And again, I've got 3. I can pick any of the 3. Kind of out of room. I guess I will use cosine squared x minus sine squared x. Well, I already know from here, cosine x, that's 12/13. And sine squared x was given 5/13. Probably should start on the top. Next page. So I'm getting 144/169, 12 squared over 13 squared, 25/169, 5 squared over 13 squared, 144 minus 25, let's see, 2 is 119. I'm getting 119/169, again, less than or equal to 1. Just to give you some confidence in the other 2, version 2, let's use version 2. Just to show you, you could have used any of the three versions. It was 1 minus 2 sine squared x. So you got 1 minus 2 times 5 over 13 squared. So then you're at 1 minus 2 times 25 over 169, which means you're at 1 minus 50 over 169, which means you're at 169 over 169 minus 50 over 169. If that doesn't come up 119, I'll quit on the spot. So 169 minus 50, you're at 9, 6 plus 5 is 119 over 169. I don't, just to beat it to death, version 3, cosine of 2x was 2 cosine squared of x minus 1. So 2, and then cosine of x was 12 over 13 squared minus 1. So you're at 2. Well, I'll do it 2, 144 over 169 minus 1. That'd be 288 over 169 minus 1, which would give you 288 minus 169 over 169 minus 169 over 169, common denominator. I bet I go 288 minus 169 and get 119. If I don't, I'll quit on the spot. 288 minus 169. 18 minus 9 is 9. So 61, 2 minus 1 is 1. There we are, 119 over 169. It's probably boring as sin for y'all, but try to give you some confidence. You don't have to do them all three different ways, but all three different ways give you the exact same answer. Tangent 2x, there's pretty much only one way to do that. We're still on page 597, problem 3. These are projects, they're not problems. Remember that was twice tangent x over 1 minus tan squared. Now redraw the picture. Okay, remember it was 5, 13, this was 12. This is angle x. And so tangent x, 5 over 12, opposite over adjacent, right triangle. So you're looking at twice 5 over 12, 1 minus 5 over 12 quantity squared. So you're looking at 10 over 12, 1 minus 25 over 144. Write it down. This would be 144 over 144. So 10 over 12. 144 minus 25 over 144. Wasn't the second time we've done 144 minus 25, then we get 119. 119, so you're looking at 10 over 12 over 119 over 144. So you're looking at 10 over 12 times 144 over 119. 12 over the 144 is 10 times, so you're looking at 120 over 119. And remember, there's no rules about it. Just means your y leg is greater than your x leg. There's no rules about tangent. That's a tangent of 2x now, don't get confused. Tangent of 2x, your y leg is greater than your x leg. Tangent of x is 5 over 12. 2x, you're further around, and your tangent becomes 120 over 119 at 2x. Just to give you some confidence in it, to beat this to death, you could have done it from tangent 2x, instead of using the straight tangent formula as a sine of 2x over cosine, since they already had you figure sine of 2x, sine of 2x over cosine of 2x, since you'd already figured sine, probably been easier to have done it this way. The sine of 2x, if I can reach it back, the sine of 2x worked out 120 over 169. Clear out 120 120 over 169. And your cosine of 2x worked out 119. I did it three ways. I should have it memorized. 119 over 169. You can almost see in your head it's going to work out because the 169s are going to cancel. Over 169 times 169 over 119. Boom, boom. And there is your 120 over 119. So probably, since they made you do sine of 2x over cosine of it, individually, had you do these, you could always do a tangent by dividing those two. And you notice you get the same answer as the straight tangent formula, which worked out a lot longer. But do it your way. Okay, we kind of picked and chose. I want to make sure I pick out problems that I didn't put on the assignment sheet. With the 3 to 81. Okay. Let's see. Let's jump down to half angle formulas. I don't think I'll beat these to death in the interest of getting more homework in. You pretty much, hopefully you get some confidence in these things. Half angle formulas, they show you here. Well, you really have to see these formulas for lowering powers. Kind of moving step by step. Formulas for lowering powers, where do those come from? Again, I won't beat them to death. All right, you really need your cosine of 2x is 1 minus, let's see, should I start with the first one? Well, I think version 1, cosine squared x minus sine squared x. Okay. This is called formulas for lowering powers. All right. Solve for sine squared. Actually, you might need the version 2, I guess. So you remember you have 1 minus sine squared. Just do it again. It's cosine of 2x. Yeah. So cosine of 2x is 1 minus 2 sine squared. Will it not catch up? Okay. Solve for sine squared. Well, you'd have cosine of 2x subtract 1 is negative 2 sine squared. Divide by negative 2. Twist it around. Cosine of 2x minus 1 over negative 2. And then they like to work it out, get rid of this negative. So you can switch the order here. Sine squared of x would be 1 minus 2 cosine of x over 2. Totally butchering this. One more time. Sine squared of x would be 1 minus cosine of 2x divided by 2. Your negative there makes the one turns positive, and then you'd have a negative there on the cosine, so they switched around, write the positive first, and that is your first version of this. It's used for reducing or lowering powers. You start with a square power, you get a 1 power. Second power here, 1 power. What it does, but it makes you convert the angle to a double angle. Your angle doubles, but the power reduces. Doubles the angle. Okay, and then if you use version 3, cosine squared of cosine of 2x is twice cosine squared of x minus 1. And again, solve for cosine squared. You'd have cosine of 2x add 1 is twice cosine squared of x divided by 2. They like to switch it around. Cosine squared of x is then 1 plus 2x divided by 2. Notice both sine squared and cosine squared go to cosine of 2x. But the sine squared's got a minus, the cosine squared's got a plus. To get a tangent squared, you divide sine squared up by cosine squared. You could almost see what happens. You'd get this top over this bottom, and the 2's would cancel. Okay. And so you get these 3 formulas. Then they go on to what are half from these, go on to half angles. So let's try to keep this one in picture. For half angle, start with sine squared. Cosine of 2x divided by 2. Solve for sine. So that means I do a square root. Cosine of 2x divided by 2. You get a sine x equals plus or minus square root 1 minus cosine of 2x divided by 2. And then they sub in u over 2 for half angle. So x equals u over 2. U over 2 equals plus or minus square root 1 minus cosine 2 times u over 2 all divided by 2. Catch up. 2's here cancel. Sine of u over 2 equals plus or minus square root 1 minus cosine u over 2. So it brings the angle back to a straight angle when you start with a half angle. In effect, the angle doubles. So half doubles, cancels the 2's, brings you back to a full angle, and that is where they get this. Cosine u is near identical, it just has a plus sign in it. Again, you solve it out from this. After a while, this gets overwhelming. I get it. Cosine of u over 2 square root 1 plus cosine of u all over 2. Okay, yes. Choice of plus. Notice this is where things get tricky. The choice of plus or minus sign depends on the quadrant in which u over 2 lies. That comes up in the problems. After a while, this gets completely overwhelming, and we're 35 minutes in. So if I'm going to work any more problems, I need to be getting on to them. You get 2 more groups of formulas, and hopefully you just believe them. It's really hard to derive them in any kind of time. Product to sum formulas. It starts with sums here, and it converts to product, or you can think of it as products and converting it out to sums. If you want to, well, I can't resist almost showing you where one of them comes, because it's not total gibberish. So page 595, show that a sine of u cosine of v is equal to a big a half the sine of u plus v plus sine of u minus v. I'll show you what you have to do to show. It's a matter of subbing in your formulas from, was it 7.2? And then watching all the pieces dissolve to this, meaning you're going to get a 1/2. If you remember, this went sine, cosine, plus cosine, sine, plus, and I'll put in this piece, sine u cosine v minus cosine u sine v. All right. So cosine u sine v minus cosine u sine v, they're gone. Sine u cosine v, that's twice. So you get a big 1/2. Twice cosine v, 2's cancel, and there you are. So it's a way of expanding products into sums. See, the other three are really similar. And then you can take a sum of different combinations and they go as products. And it's the same idea. I can expand these out by those sum formulas. I don't know if you got the patience for it. Hopefully you believe this by now. And that's where you get them. Of course, you'll be able to use these on the test online. I can't prevent you from using formulas like I could in the regular class. Let's see if we got time for any more problems. Like I say, they're burying you in formulas here. I think this is the last of the formulas, though. The rest of it is solving equations, but you'll be using these kind of formulas to solve equations. Let's see. Let's try page 597, a half angle formula. 17, a sine, 15 degrees. We'll catch up. And use a half angle formula. All right, well, now remember you used u over 2, or we could use an x over 2. Maybe I'll just use x over 2. Meaning x over 2 would be 15 degrees. So this is like matching to sine of x over 2. X then is going to be 30 degrees, because if you multiply both sides by 2, you'll get 30 degrees. X itself is 30. So there is 30 degrees, or divided by 2 gives you 15 degrees here. If you remember, that was plus or minus square root 1 minus cosine of x over 2. I'm just using x instead of u. Sine of u over 2 is plus or minus square root 1 minus cosine u over 2. I'm just using x over 2, 1 minus cosine x all over 2. So once again, that's a sine of 30 degrees divided by 2. That's my sine of 15 degrees. That would be equal to plus or minus square root 1 minus cosine of 30 degrees. So the x is 30. The x over 2 is 15. This is x over 2. X equals 30. All over 2, and it's all under a square root. The rest of this is just trying to massage it into their form of the answer, plus or minus square root 1 minus the cosine, if you remember, of 30 was cosine 30 is the x legs long. It's root 3 over 2, all over 2. I usually let people quit at this point because the rest of this is just nothing but nasty algebra. But if you want to see what it is, 2 over 2 for that one there, you'd have plus or minus square root 2 over 2 minus root 3 over 2 all over 2, which would be plus or minus square root 2 minus root 3 all over 2, which is going to be plus or minus big square root 2 minus root 3 over 2 times 1/2, because remember this would flip. That's going to be plus or minus big square root 2 minus root 3 all over 4. And then that square root of 4 on bottom, that's going to be plus or minus big square root 2 minus root 3 all over 2. But the trick is, which is it? Or minus? Well, remember, it depends on quadrant. By the way, this was equal to sine of the x over 2. Well, remember, this was 15 degrees on sine, which is equal to 15 degrees. Well, that's quadrant 1. Sine is positive in quadrant 1. So final answer, ran out of room. Sine of 15 degrees winds up being positive square root 2 minus root 3 all over 2. Let's see how close I got. That was 7-3. Problem 17. 3:17. Okay, they pulled the half to the front. So they got the square root of the 2 minus root 3, pulled the half to the front, meaning they wrote it as 1/2 of square root 2 minus root 3. This is the book. So hopefully you recognize it's the same. All right, I pretty much let people quit pretty much right here or right here, as long as you can pick the proper sign. See if it would catch up. Pretty much let people quit like right here, if you can pick the proper sign. All right, ooh, 842. Let's see, further down the page, 29. Part A, find exact value or simplify of 2 sine 18 degrees cosine degrees. Well, it's kind of using double angle backwards. So if you look back at double angle, twice sine x cosine x is equal to the sine of double whatever that x is. Meaning this is the x, this is the x, match it to twice sine x cosine of x to sine of twice that x. So that means your x is 18 degrees. This must be 2x 36 degrees. So this is equals the sine of 36 degrees. That's not a circle value. That's some, crazy decimal. So imagine they just left it like that, or simplifies the sine of 36 degrees, whatever the heck that is. Double the 18. If you want, it would be at 36 degrees. It would be the y leg sine of 36 degrees. You could get a decimal. You could get a decimal. But it's the y lay, you get 36 degrees. What else? It's just an exercise in using the formulas. All right, let's see, using a half angle. Oh, those are real projects here. I guess we have time for one. Let's skip down to 43. Try to remember what I've done this Zoom session in 43. Find formula for sine of twice arctangent x. Well, sine of twice, I'll use a theta then. Remember, it was twice sine theta cosine theta. So that is going to be twice a sine of arctangent x cosine of an arctangent x. Theta being the arctangent x. Triangle. X, 1, opposite. Same triangle for both. Square root 1 plus x squared. Okay, and can you see that sine is x over the square root of 1 plus x squared? Cosine 1 over the square root of 1 plus x squared. Plug in the sine for all of this and the cosine for all of that. You would get twice x over the square root of 1 plus x squared. 1 over the square root of 1 plus x squared. Well, your top 2x times 2 times x times 1 would be 2x. And on bottom, your root's identical. It would just drop 1 plus x squared. And you could punch an angle up here and an angle here, an x here. Actually, an x value here, an x value here. And you get the same answer. But I won't take time to do it because I need to stop and record this Zoom and get ready for the next Zoom. So we will pick up on a lot of the rest of these in this section are pretty straightforward if you plug and chug into the formulas. Proving identities uses a lot of these formulas as well. It should be pretty, at least it's straightforward for me. But we'll work more of these problems on Friday at the next Zoom. Hope this helps. Hope this gets you started. We'll pick this up on Friday.